Hey, how are you? Welcome, welcome, welcome. How are you? We are going to be enjoying today 1 hour of some engineering lecture about systems integration and technology for architects and spaces. So it's going to be a fun session today. And thanks very much for attending. And we will be using both our chat to communicate with you guys during the lecture. We have Ivan with us today that will be my co-host. And also you can use the Q&A section for questions through any moment during the presentation. So you can use that as you wish. And then, of course, at the end of the lecture, we'll have a special moment for Q&A in detail. But please feel absolutely free to interrupt, to ask during the lecture, and we'll have some fun here talking about systems integration and technology in architecture. That's the name of the lecture today. My name is Sergio Molho, partner of WSDG, Walter Historic Design Group, and we are doing this AIA lecture today for all of you guys. Now it's on time. We are on time now. Thanks for all of you guys that attended on time. That's a good sign. But we are going to wait a few minutes more for the rest of the attendees to come in. Okay, we have a very nice registration number today, so it's growing by the second, as I see. And in 1 minute we will start the show. Again, this is an AIA lecture. It gives credits for your AIA license, and also the HSW 1 credit too, and will be fantastic. And we have a guest. Good morning, John. How are you? You have to unmute yourself. Let me unmute you. Hold on 1 second. I will do it for you. Yes, you're on mute now.
Hello, everybody. I didn't know I was going to be a guest. I thought I was going to be a participant.
But you can mute yourself.
Turn
off the video.
I'm happy to be a guest. Everybody, I'm not quite sure who is everybody, but very strange talking to people you can't see. But welcome on behalf of WSDG. You're in very good hands with Sergio. I'm going to disappear in the background.
Okay. Thanks, John, for coming. John Storick, the legend, founder, partner of Walter Historic Design Group, the company that I'm partner of, one of the leading companies in the fields of acoustics and systems integration in the world. So after giving a few minutes for the rest of the team to arrive, okay, I think that we will start. Thanks again for coming. So I will go through the usual actions here. And here we go. So, what is the subject today? Let me put up my desk a little. Let me get a little more organized here. Very good. We're going to be talking about technology and systems integration in architecture. Okay, and this subject I think is super up to date now that we are all depending on technology to communicate by ourselves, by working at home or working remotely, and systems integration never has been so vital for the survival of our species. So let's take a look at what that means. Again, my name is Sergio Molho. I'm partner of WSDG, Walter Historic Design Group. We are a firm that we develop everyday architectural acoustical consulting and media systems engineering. And that's what we are going to be talking about today, about systems engineering. And we are a worldwide company. Our headquarters is in New York, in Highland, New York, and we have offices around the world. I'm now in Miami, Florida, and we are part of a big network of engineers, acousticians, architects, designers, all kinds of people that are related to this trade that is making architectural spaces sound good and be wisely connected. We are part of the AIA, continuing educational system, and this lecture will give you 1 credit for your AIA license. For the ones that are not licensed, but you want to receive, you're going to receive a certificate of attending to this lecture, which I think that you will like. And Ivan, that is our co-host today, please, if you have your AIA license, just put it on the chat or put it on the Q&A, and we will send you the certificates. And for all of you guys that are not AIA licensed, you're going to receive that certificate, a certificate from us anyway. So what is the challenge? The challenge for us on our day-by-day is to unite the disciplines of architectural acoustics and technology in order to create an amazing space that sounds good, feels good, and is acoustically accurate and technology positive. That means that you can use that technology that you need for your space in order to have a better building, a better space. And architectural acoustics and technology has been with the humanity since long time. This is a very nice amphitheater in Jordan, and in some way, the people who designed this space were finding out that this shape of the space allows people on the stage, normally politicians or maybe some theater, to be listened more clear through the audience. So in some way, the understanding of sound and communication and technology was present even from before the AED. And the same happens with this fantastic theater from more than 100 years ago. We really don't know the amount of science behind the shape of the theater, but no two ways about it. It contributes to the experience of the artists, the entertainers, and the audience, okay, before the loudspeaker era, okay? And the intention of giving this lecture is to broaden our network and our connection through all architectural firms and your architects, and we would like to express our interest on giving our knowledge, our experience in this particular field, and what we do every day is related to architectural acoustics. Okay, we are consultants in the field of acoustics. We do acoustic measurements, sound structural acoustics, and sound isolation studies, internal room acoustics, and everything that is related to noise and how to control it and to keep it under control. And then when it comes to media systems engineering, that is the subject of today's lecture, we design electroacoustical systems and systems itself, anything that has an on-off switch, like IT and communication systems, of course, home theater and residential, and theatrical technology and control systems. And we are going to go deep into this particular subject and trade today in today's lecture. So this is like our mission. We try to listen to our clients and the project needs. It's good for us to be working with sound and trying to listen. It's like a kind of a joke, but sometimes it doesn't work like that. We really believe in strong programming. We believe that starting strong on programming and understanding that project intent is vital for the rest of the path of the project life. We want to coordinate architecture, basically your design, your ideas, your vision, acoustic, that is the space of that and the behavior of sound inside of that container, and the technology as one integrated design effort. And we try to spend all the money of our clients. No, that's a joke. We don't. We try to be soulful and economically responsible. And of course, we respect the art of design. We understand design. We are all designers by heart, and we try to apply the science and the acoustics and the technology into that design. That's what we do every day. So this subject of technology is present in any kind of size of project. So even from a large, ridiculously large stadium, 100,000 seats in China, which, as you can see in some of the renderings from the vision of the architect's technology, you cannot define what is technology and what is architectural in this idea. So anything that is related to that, as in any kind of large space like stadiums, LED screens, speakers, safety, large controlling systems for the access of people. If the stadium has a roof, now it's an arena, but the needs are more or less the same. Look at the importance of technology on an NBA arena, okay? Screens are everything. Sound is everything in the experience. And the same happens when we go to a very specific place like a concert hall, that music and technology is everything, okay? Theaters of different size, college theaters, educational theaters, conference room, corporate auditoriums. Technology is part of the program from day one. That is the key. In some of the cases, technology is so important that even the project starts with technology people before architects, which is because of the use of the space. But in any case, with whatever level of technology is implied in the space, architect vision is what rules the project. The user rules the project. The vision and the kind of space that you want to witness and to have is what rules the project. And in whatever level of topography, look at the amount of technology in this tiny little club in New York City, Le Poisson Rouge, very successful one. Technology and architectural are married together going through the program, okay? Even if the technology is as invisible, and in these minimalistic multipurpose rooms, there is a lot of technology behind the scenes going on. And how we will manage that technology through the space is critical for the program and the experience of the users. And of course, if we go deeper to a recording studio or a space where technology and acoustics is a must, all this subject, it's more critical and requires more attention in every single detail. And today, the spaces are intent for music creation or content creation, looks like living rooms, and today living rooms look like content creation spaces. There is even no boundaries. The boundaries disappeared, and they are completely seamless when it comes to spaces that are related to content creation, performance, or basically just to listen or to watch a movie, like in these cinemas, okay? So all this trend had a big affection, a big impact on the architectural design and in all the other consultants through the food chain, okay? In the spaces where technology was just for safety, like in a mall today, the malls and all these public spaces are required to have more interesting and more robust systems for different reasons, okay, for different reasons. Speech intelligibility, safety, announcements, okay, entertainment, everything is kind of mixed up. And from the 100,000 seat theater or stadium to a home theater, 2 seats, okay? Everything is related and everything is connected, and this is what we're going to explore today during the lecture. So again, the buildings, okay, that we are designing, that we are talking with, now the buildings also talk, okay? They are not only listen. The building talks to our audience, talks with audio, talks with video, talks with lighting, talks with system, with digital signage. There are different ways that our buildings are interacting with our audience, our users, in different ways, in completely different ways. But all these factors have something in common. You need a robust infrastructure to support that conversation, that communication. And that infrastructure is completely related through the entire food chain of architecture, interior design, MEP, and all the other consultants, structure, and all the other consultants through the process, okay? From front of house, what we call front of house, that is basically where people, the users, are walking through your spaces, to what we call back of house. That is, all the spaces are required to control that kind of network and a complex array of technology. So, in order to understand where we are now and where we are going, it's always kind of good to see from where we come from. And in the evolution of the audio and visual experience, okay, the first audiovisual experience is basically in ourselves, our eyes, our ears, okay? And the audiovisual experience starts when even when we are inside of our mommy's belly. All our senses are starting to get information to our brain and giving us a sense of space, okay? So we understand sound and visual, light, and starting to start on a 3D, okay? Imagine that we are showing a prehistoric image with a 3D sense that is from our times. The 3D experience is what we have every single day of our lives, okay? And that idea, that is what our brain is doing. Basically, our brain is digesting between our two ears what comes faster, okay, or with more level than the other ear, and that gives us the sense of direction. And that information is critical for us to understand where we are, okay? That's why also when we have some hearing problem or some dizziness problem, we are losing that sense of dimension, and that gets us crazy. That's what's going on. And we are having experiences related to audio for a long, long time. And in 1877, we, for the first time, we were able to record that information into some kind of media, okay? And this was the beginning of what we call the modern technology in terms of the audiovisual recording and experience. Different kind of crazy devices at that time. The quality is also related to our ability to converting those waves of sound into some kind of media and record it, and then the magic was to reproduce it back. That was the magic, to be able to play it back and allow people to listen to what happened, okay? So we are fast forward a little, and a recording facility in 1950s, that's what a recording studio looked like in that time, and you're starting to see some of the devices that allow us to record music, to process music, and to play it back, okay? And then that converts our life into what we all enjoy every day, okay? Here we have the Fab 4 at Abbey Road Studios in London. And also the playback experience got improved, okay? We have better speakers. We used to have these ugly boxes in different types and shapes, and then the Walkman arrived, so that public experience converted into a personal experience, but more or less the content was recorded and played it back, and we were able to have the different experience in different ways. People have very strange ways of listening to music, but that's the magic of it, because we can enjoy the content in any way, and that experience at home also evolves, okay? And all these changes in technology are affecting the way we think about technology related to architectural systems and related to architecture and how people move inside of the spaces. So from the very bad image / sound of the first black and white TVs, and thanks NASA, then we got color, we got stereo, we got VCRs, video games, Betamax, and all the shenanigans that we all been witnessing the last years, till we grow to an interesting streamed digital media with different types of displays and content. But notice something. there is always a playback, okay, a playback device, and a user, a listener, or a viewer, okay? And what we're going to study today is what goes behind the scenes for this experience to happen, and what changed and what will continue changing. So in terms of the production of the content, because everything that we are listening or viewing, etc., comes from some kind of content. Also, we have huge advances, and this is where John Story was here with us a few minutes ago, started his career. On the lower left image, you have Electric Lady Studio, Jimi Hendrix Studio, designed by John in 1969. And this is how his career started as an architect, acoustician, and these spaces also evolved as the technology evolved with us. So today it's very difficult to say if we are watching at a recording studio or a place where we can create music, write music, or at least just listen to music in a very elegant way. And technology evolves, and the experience now goes to unknown horizons, okay, like VR, AR, where we can have the full experience without even knowing where we are, which is sometimes it's a kind of scary, but it's part of the reality of the different kind of performance and playbacks that we can have today. And we can even be able to have our surround 3D, remember the 3D image of the prehistoric with the tiger and the guy? Now we can have that same immersive experience without being in the space, in your pocket, okay, through your headphones. So let's go deeper to that. But this is the world where we are living, and we as designers, architects, we need to be able to respond to that reality. We need to satisfy users that we are living day by day surrounded by this kind of technology, this kind of experiences, and they are expecting our buildings, our spaces to respond to that need, okay? And basically everything is related to our infamous phone, smartphone. I don't know who is the smarter of the two of us. I guess that the phone is smarter than me. And that also affects our day-by-day experience as humans in our landscape today. So the subject that we are going to go in deep today is about systems integration and technology, and I would like to draw a line, okay, between what we call as low distribution system voltage, LDSV, that normally we call it here in America low voltage, okay? Basically everything that is related to something that if you touch it, you're not going to get electrocuted, okay? Low voltage, that's the meaning of that. So an audio cable, a video cable, a signal control cable, etc., etc. And versus main voltage. In the US, again, 100 volts or higher, depending on what system you are. And we are going to focus today on the low voltage system distribution and integration. Of course, our low voltage system requires main voltage or voltage in order to operate, but we're going to focus on the infrastructure required for the low voltage systems. So, as in any trade, program rules, okay? So when we are starting the system design and technology integration design, we need to understand what we are doing. We need to understand the program, the architectural program first, other consultants' program, what their requirements from the other consultants, and in particular, what is the need of the space and the user. We need to listen to that. We need to understand that to facilitate that information in a very clear way to the other consultants, so everybody is aligned under the same umbrella, okay? We need to seamlessly integrate that information, whatever that information is regarding the building use, okay, through all the stakeholders, okay? That education creates democracy, that education creates synergy between the parts, and then at the end of the project, nobody can say, I didn't know that you're going to hang a 6x6 large LED screen at the lobby of the hotel. Okay, and that happens to us before, and the infrastructure was not there, or nobody was even thinking that that object will wait, that need to be supported. Okay, those things are the ones that we need to avoid by a huge, sophisticated, complex program analysis. And the process, when it comes to technology, and systems integration, we are part of a complex array of participants and stakeholders and processes. We are, as architects and designers, you're all familiar with this kind of scheme. Okay, we have a program analysis, we have to define what we are doing, and do all the exploration, all the discovery part of the process. When we have that, then we can go to and start designing and explore and personalize that design, and even render the view of that vision, of that design, and then we can develop and we can create technical developments or 3D modeling, etc., all the engineering, the CDs, and the implementation, documentation, whatever is required to make it happen. And of course, in the end, we need to make sure that it's being built as per the specs. Okay, so better the program analysis, a better defined program will give us a better design. A better design will give us a better development and construction documentation and bidding documentation. And the better the package, the better the outcome. Okay, there is no project with no RFIs, but you can tell the quality of your documentation by the amount of RFIs during the process. Okay, that's for sure. The same happens with technology. We are part with one of the pieces of this puzzle that you have in front of you. And so in this detailed programming phase, okay, we need to understand all the spaces divided by types. Okay, it's for example, let's say we are doing a hotel. Okay, our lobby, the guest rooms, the ballroom, the bar, the restaurant, the back of house, all different types of space with different needs, different finishes, different needs, different user experiences, different management experiences. All needs to be addressed in terms of technology integration. Then we need to be side by side with our MEP, with the MEP team. Sometimes low voltage is part of the MEP team. Sometimes low voltage is coming from the MEP team. And there is a portion of it that needs to be specialized, and you hire a specialized consultant for that particular place. But most of the low voltage management is done by an electrical engineer. That's very common. Okay? But in any case, you will have a complex wiring management that needs to be addressed in documentation that can be built. Okay? And that information and all this complexity will need to be addressed by an adult project manager, a management process. And this is something that we've seen a lot, and this is why we added here the presentation, that sometimes when it comes to technology integration, the design or some of the decisions, the key decisions, are not ruled by design or by program, they are ruled by equipment sales. I'm not in contrary, I have nothing against people who sell equipment, but each of us needs to have the right spot in a project track, okay, and timeline. Equipment is critical. Someone has to sell it, someone has to install it, but before thinking about how much we are going to sell, how many TVs we're going to provide, what is the largest and the better quality of the TV, let's talk about the content. Let's talk about the experience. Let's talk about the program and what will happen in that space before starting to go deep into, I want the sharp LXUWT. That's not relevant when we are on these detailed programming phases. Okay? Sometimes there is one element that is mandatory in the system, but normally it's one element that is mandatory that could have a brand and a model, but normally the rest of the elements are brandless. Okay? What we are looking is functionality and specs. That's what is key, the spec sheet and the functionality of the space. And of course, all these ideas, all this content is coming from standards, and we love the standards, we use the standards, and we are embracing anything, all the organizations that are related to creating standards for us, like CEDIA, ABIXA, NAM, and of course AIA, and all the standardizations that we have. And I'm sure that you noticed that in the tech world, in the nerd world, the techie world, we love acronyms. BHS, CD, BZR, HDMI, all these words, and this is our nice way of trying to summarize crazy words, because and this is how we relate to it. You don't need to know every single acronym, every single word that is in the horizon. That's not what you need to know. What you need to know is that all these words are related to something that is related to the use, or the object, or the way we connect the object. And we're going to go with that. So what are the traits, what are the different actions that are related when we are talking about any kind of building? Okay, when I say any kind of building, it could be a single family house or a high-riser, okay? Systems integration, low voltage design are normally related to the connectivity between audio, video, automation, control, network, IT communication, data, internet, everything that goes through that way of communication, CCTV, security and access control, alarm, fire, safety, HVAC control, power control, and lighting control. So all those are the traits. Those are the different aspects that are interconnected through this systems integration design, okay? And each of them has its own particularities, each of them has their own needs, and some of them are the ones that we as designer needs to come up with the solution of equipment specification, control, and management, and infrastructure. Some of them are coming from other consultants, like, for example, security, alarm, air conditioning. So we have other consultants that are related to the design of those systems, and our goal will be to interconnect them with something else. And what is that something else, which is what we are going to discuss now in the next minutes of the lecture. So in terms of infrastructure design, okay, we need to think about anything that has an on-off switch, okay? Imagine, close your eyes, imagine your building, your space, any space, your living room, the place where you are now, okay? Now look at every object that you have surrounding you and think about the on-off switch in those devices, okay? Lights, yes. Computer, yes. Audio, yes. TV, yes. Alarm, yes. Fire detector, yes. So everything that has an on-off switch, sooner you can interconnect them in some way that they are talking to each other, okay? And if it's one room, that interconnection seems to be not that complicated. When you have 30 stories of a building with multiple apartments, multiple guest rooms, multiple office, conference rooms, ballrooms, reception, lobby, blah, 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 that infrastructure, that topography, it's starting to get crazy and more complicated and needs real documentation, needs real engineering for that to happen. And this is our goal, to have water coming out from our louds. No, that's a joke also. But this is a real picture, by the way, okay? So this is what we're trying to avoid. And I'm sure that you all, as professionals, have seen this kind of schemes before. The smart home or the smart building that has some kind of centralized system that talks to all these different trades that we just discussed, okay? As you can see here, HVAC, lighting control, smoke control, quality services, water management, pumps, electrical, blah, blah, blah. Everything to be controlled, no matter the size of the object, by some kind of centralized system, okay? The only way of doing that is to have a centralized system. Because if not, you have the same kind of services, but they are not talking to each other. Sometimes you don't need them to talk to each other. Okay? Not every building will require a centralized control system. Every building will need the services, okay? So that's also important. Sometimes you don't need to go crazy trying to interact all these services into one unified control system. But if you want to do it, okay, which is something that we will continue exploring, is what we have, this building management system that, think about it as a very smart computer, okay, with a very smart software that allows you to communicate MEP, electrical, air conditioning, lighting, pumps, water management, etc. Each of those systems will have some kind of interface between them and this mainframe, this computer and software compound. Okay, we have the safety system with fire, smoke detectors, PA announcements, alarm, access control, CCTV, everything that is related to the safety of our environment. Okay, and those systems will be connected to our centralized system, but also to systems that are outside, like police station, fire station, etc., etc. So we're starting to have connectivity inside and outside of our building. Then we have the IT, very important today, your entire network that will manage the connectivity to the outside world with the internet or with your telephone company or your cable company, data management, telecommunications, intercom in between the building, and of course Wi-Fi. That is something that is growing and getting every day more and more robust, with the use of not only the Wi-Fi internal system, but also the Wi-Fi coming through 5Gs and newer technologies that are coming from our cellular phone system. And last subject will be entertainment. So everything that is related to the audio, video, digital signatures, Zoom management, etc., etc. So you can see that IT and entertainment, there used to be a very interesting and deep line between the two of them, but today those boundaries between the IT management, the network management, and the entertainment, those lines are disappearing. Now we can think that management of IT and entertainment are coming from one entire and unified source, and we're going to see that now in the next slides. In the end, whatever the size of our buildings management system, BMS, okay, is, you will have the user, that could be the individual user, the manager of the building, or the owner of apartment 1546, okay, will have some kind of interface to relate to that interface, okay? That interface will be tailored as per the spec of the building and the need, okay? You can have different user levels. You can have the manager level, the concierge level, or you can have the individual user kind of interface or display with different kind of elements, and you can even have Alexa to be your voice recognition interface, okay? Alexa is a building management system condensed into a very easy do-it-by-yourself element. Okay, that is Alexa. Alexa is a building management system, but we use it for a home environment. But in the reality, Alexa is communicating, as I just explained, is communicating with your HVAC, with your thermostat, with your alarm, with your lights, with your audio, with your video, and with anything that you want her to be inside of your house. At your own risk, by the way. She is listening. So now that we determine our environment, okay, this is a building management system. This is a system that can manage a rocket flying to the space. So this is a complex system. But even if you're looking to this crazy picture of this massive mission control room, in reality what's going on here, because of the complexity of the system, is that all the different elements that are related to that rocket to be launched, okay, are condensed into one unified system that has a project leader, okay? And when it comes to a building, that project leader is the maintenance guy, okay? The building manager, or if it's a smaller environment, that manager is a computer, okay, with a pre-programmed set of tasks and in order to proceed. But this is your mission control. When you have your building being managed by a system, you have this inside of the computer. Then we can talk about the size of that computer and the system, but everything goes like that. And we can go smaller in size, and this is a very nice CCTV kind of control room, okay, security control room, very fancy, but in any case, this is the building management system of a very particular building, okay. Again, you can manage the building with a large mission control, a smaller control room, or even from an iPad or your phone, okay. So the interface of how we are related to that has nothing to do with the object itself. It's related in terms of size, but the final interface to make that control happen will be determined by the size of the project. The most important thing is how all these elements are connected by themselves. Okay, and normally they do through these kind of rooms. Okay, rooms where we have a lot of connections of different types, network, audio, video, interfaces, control, that are coming into a centralized mainframe, computer system, okay, and everything comes from here, and from here you have the interface to control it and to check the status of each individual system. That is the way it does. So that's why the space analysis, when you're starting a project where you need that to happen, the space analysis for this room is critical. This room needs to be in a clean space, air conditioning in a different way. It has to be secured, because imagine if you get in here, you can do serious damage to your building and your network, okay? And the definition of that space is critical for the performance of the task, okay? So do not underestimate the need of a central machine room or a control room or a rack room, a rack closet when it comes to building management if you want to manage a lot of things, because basically you're starting to need space to put these toys. Okay, so that's very critical for you as architects. When you're designing, you're in early steps in your program analysis, add CMR or control room or audio video closet or whatever you want to call it, but please add it into your program and spaces. If you are in multiple stories building, you need to have at least a little version of it in each floor in order to interconnect the different floors between each other and then go to the mainframe, then go to the controls room. Okay? If those rooms are one on top of each other, and then you can have a plenum path, okay, vertically, the interconnection will be easier and cheaper. Okay, that's also a good advice. Okay, the other good news is that as we are going to a world that is more network connected, that means that most of the data is managed by some kind of network, we are using less copper. That means that the need for wiring, the usual, the big chunks of cable of copper coming in and out for audio, video, and other trades are being reduced because of our way of being able to connect all these elements using some kind of network connection, okay? And all these different elements will finish on panels, okay? The interface between the generator and the building management system will be a panel, something like this. If you don't have a building management system, the generator itself will also have a panel, because if you don't connect it to a bigger mainframe, you will need to access to it in any case, with no doubt. So there will be a need for some space for panels that are not the electrical panels. There are panels related to this kind of control, of low voltage control. So you will have what we call the low voltage panels, the control panels, the automation panels that are different than the electrical panels that are completely different, as you can see in this image. So they could coexist the low voltage panels can coexist with the high voltage or main voltage panels? The answer is yes, but sometimes because of exactly this topography and the way we manage wiring, they are separated, okay? Electrical engineers will prefer those rooms to be separate. I think that as systems consultants, we can coexist with this kind of panel, but sometimes even it's better because at the same time you have the low voltage panels, you will have some racks, you will have other equipment that would need to be addressed, okay? And the answer is, what a building management system will do with power. Okay, it can check status, that all the phases of all the sections and all the different subpanels are live, are in green, okay? So sometimes building management system is not to action to the panel, but only get a status report, okay? And this is very normal, okay? You don't want the building management system to turn off your panel, which it could, but sometimes you don't want that. But you do want your manager, your building manager, to be able to check the status of the panel and the status of every single subpanel and every single element of your system, okay? And again, this can be checked with his phone because that's the interface. It has nothing to do with the control itself. As I just mentioned, we can low voltage and voltage panels can coexist. That will create a more complicated layout and room, but they can live in the same space. It's just a matter of design, okay? And audio-video rooms that you are all also aware of them and how they operate, etc., it have also evolved during the time because we moved from the analog era to the digital era, and from the digital era, that is the era that we're living now, we're evolving to what we call the AV over IP, and we are going to talk about this particular subject now. And because of this analog to digital era have evolved, of course, those audio and video control rooms now are smaller, requires less power, requires less air conditioning, and they are smaller in size and style. But very interesting to find out that the audio and video over IP has been a huge improvement in technology in the last years. That means that we have the audio and video outputs, you know, sound, microphones, speakers, cameras, etc., that information, that signal that was analog was converted into digital, and now that is in digital, we have the ability to convert that digital information using specific encoders to a signal that can be managed by a typical IP switch, okay? The information will be encoded and decoded using very specific protocols, but now instead of transmitting analog sound, for example, through copper speakers or for amplifiers, etc., now we are converting that into digital, and that digital information is now converted into a very specific protocol that allow us to decode, encode, and decode that image, that file, that packages of data using a typical IP network, which is very important, which is very interesting, because now when you want to talk from one portion to the building to the other, you can use regular network cables, Cat6, for example. And that information that goes through a regular Cat6 cable can be connected to any regular switch, and with the right protocols, then process that wiring to the next part of the building or another building where that information will be decoded and converted into a video display, a projector, a speaker, or whatever kind of element you are transporting. And this is huge, okay? That means that from the old era where we arrive, the cable company arrives with multiple wires, multiple copper, and then distribute through the building with more copper, etc., we have now the possibility of converting all that into network IP solution. Okay, and that brings us a whole new array of possibilities for managed audio and video signals inside of a space or interconnected that building into other buildings, even using fiber or the other technologies. Okay, and this is what's coming up in our lives. More audio and video connectivity over IP, and of course more wireless connections by Wi-Fi networks and using 5G cellular technology. Okay, this is what comes next in our horizon. So that means that these rooms that used to be super complex, and the backbone of this kind of enterprise was super complex, now it will be converted into kind of a rack room of a server room. Okay, it's a smaller footprint, easier to manage. Every single object will have an IP address. That means that we can identify every single at any time with an exact address, and we can talk to that address bidirectional all the time, which is fantastic. And continuing with the CCTV, from the world of these analog cameras, the typical cameras that we used to have in our properties. Remember, those cameras will require the video signal connection and also power, because they need power. And now the digital cameras that in phase, they look more or less the same, but now those cameras can also could be powered. Okay, PoE, powered over the Ethernet, will be powered with the same Cat6 cable. Okay, new advances. So now when you have a camera, you don't need one box from the electrical and one box from the low voltage. We just need one connector for your low voltage network connectivity. Okay, that's huge advance in this particular field. And the same happens with the access control. Access control used to require a pretty complex array of connectivities. And when it comes to doors, that was a nightmare. Of course, all this access control can be also powered over the internet, and what we used to have, like fobs or the print of the finger, biometrics, whatever system you're using for that access control can be completely integrated into your infrastructure and topography. Okay, everything seamless into the same system. So it seems that technology and the development of technology is taking us to that new horizon where this centralized building management system that was science fiction or exclusive for very specific and complex buildings in the past, now it can be used at basically any building, because first of all, the infrastructure is easier. We use only one protocol, or not too many protocols, but one way of connecting spaces to each other. We have the central machine rooms. We have the interconnectivity between the different spots, the different places, with an individualized IP address for each individual object that can be managed using this computer software hardware mainframe. Okay, so that is the present and the future of what we're doing every day. Continue with the same digital displays. The amount of progress in the display area is amazing. We just seen a few weeks ago the new completely transparent screen. That when I mean transparent, it's a piece of glass that magically appears to have an image like Minority Report kind of thing, but now for humans, not for Hollywood movie. Okay, displays are thinner, create less heat. Okay, are lighter, easier to connect. Okay, again, can be connected using the same kind of digital connectivity, and they can be placed as an architectural feature. But again, remember, if you want to place it, sooner or later, they will require infrastructure behind. Power for determine the type of object and connectivity. Okay, so that's something to remember. So how we start this process? Okay, entering the last 10 minutes of the lecture, we start the process again, having a nice program, a perfect program description, trying to create some kind of system narrative. Okay, I think that that's very useful, and we find out that to be very useful because we can put in a narrative way, plain language, okay, that my man can read, okay, what the system is intended to do. And more important, what the system is not intended to do, what it's not going to do. After the narrative is approved by the stakeholders, all the entire food chain, then we can move to the system equipment specification. After that, so imagine the amount of meetings and conversations that we can have, an understanding of the building, Revit files coming in and out. Then at that point, we can start talking about equipment, because equipment, the specification is related to the spec for the engineering, but most important, the spec for the architect. The architect and the designer needs to understand what they are dealing with, okay, in terms of size of the objects, height that needs to be mounted, okay, position, weight, okay, and that will also affect the other consultants, because all that in technology, that those elements will require some kind of heat and power load that at that point we will be able to start creating the conduit layout, the topography for both power requirements and low voltage requirement of every single element that will be mounted, okay? That power and conduit layout will be converted later into the system diagram design that the one that the installer will use during the installation, okay? And of course, all of this needs to be, again, once everything is finished, needs to be again checked and coordinated with the final interior design of the space and the other consultants. So there is 3 different checkpoints at the system narrative level, at the heat and power load and conduit layout topography level, and then when everything is done, final coordination with architecture, interior design, and MEP team. Okay. Again, the process is the same. We have sources, we process that source in the flow, we amplify that signal, we have the output of that signal, and then we can control all that process using some kind of device. Okay. Process. No matter if you're talking about the CCTV, the access control, air conditioning control, or the sound at your ballroom, the process is the same. Concept is the same, the process is the same. So typical program analysis sheet that then is converted into a narrative system, okay, is like this. You have the different levels with all your rooms are numbered, because that's why you as architects, you're labeling a number in example single room, okay. We give them a name. We give them a type. We determine what is the type of room. So all the retail, for example, this building, all the retail spaces, no matter if you have 2 or 100, are going to be labeled the same, because they will have the same audio, video, interactivity, and network connection. And you can make that list as robust as you need, depending on the type of building that you're dealing, and you can determine for each particular trade what is the need. So this matrix plus the system narrative will be then converted in your starting point for your equipment list, okay? And the equipment list will follow the same criteria. You will have the different spaces, the type of equipment, then we can start creating brands and models for those equipment and have a precise description of the use and the service that that equipment can give. And of course, in our world, we are specifying a function and describe the function of the object, and everything is as similar. Most of the objects have a different option, a different element, a different brand that can perform more or less the same service. Okay. With that list, when we have that list, we can start getting power and heat loads. Okay. Every equipment will have a power requirement and a heat requirement. And that information needs to go to MEP. They need to understand where in the building that power requirement will be needed, and we also will have our heat requirements for those spaces. Okay, we are not, although we can count the heat of people. Okay, we allowed the MEP team, the HVAC team, to understand the occupancy of the space, but all the other elements that can create heat from the systems that we are inserting, it's information that both mechanical and electrical engineer needs per location. Again, everything is per location, okay, in terms of the requirements. And this kind of sheet with the estimated heat and power loads, with the diversity factor, is the kind of output that you're expecting from a system engineer to get as an outcome for your other consultants. This is the need, okay? That will determine how big or not the power requirement, the heat requirement, the HVAC requirement will be on the side of your other consultants. In the end, we can have a beauty CMR, okay? Again, remember that you will always need special areas, special rooms to place all this equipment, okay? And you will have space to manage all the wiring, to do service to the objects. Those spaces, normally you want them to be dust-free, air-conditioned, etc., with some kind of security access, because again, if someone gets into this room, it could get a big mess in your building and in your operation. All the above will be converted into some kind of system diagram, diagrammatic design, that basically different objects that will be connected with different kind of signals, okay, as many signals are required, audio, video, analog, digital, network, no network, blah, 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 blah. Everything that you can imagine, this complex array of signals, and that visual diagram will be converted into a system diagram, a system design, okay, element by element, input and output of every single element that will be managed through all this topography. And with that information, we can go to a detailed documentation of every single object and every single input and output, and that information can go into interconnection, patch base, and panels through all your building, okay? Sometimes this is just the outlet that you have behind the TV at room number 1546, okay? This could be as complex as required, but needs to be detailed, because the size will affect your architecture, it will affect your back boxes, your infrastructure, etc. And from there, you can have final low voltage drawings that needs to be coordinated with electrical drawings, lighting drawings, air conditioning drawings, placement, applied, etc., etc. So all this is all the chain that you need for this to happen in a coordinated fashion through your building, through your design. So just now ending our lecture today, we have the feeling that technology will only evolve, will only give us the chance of having more interesting and smarter and more functional buildings. And I think that we think that no ideas are possible. Remember the 3D guy and the prehistoric with the tiger. Okay, in our world, the stereo. Okay, we listen to stereo. We have 2 ears. We listen to stereo, but we perceive sound on a surround environment because we have that capability. Our brain has it. So when we convert that 3D experience as humans to a loudspeaker system, okay, we want to emulate that surround experience as much as possible. So that's why we start having more speakers, 2.0, 5.1, 7.1 now, Dolby Atmos. So make it as crazy as you want in all the cases in order to emulate our human capability of living in a 3D world, okay? All these systems, when it comes to the audiovisual experience, we are trying to emulate what we have every day while walking through the streets. Okay, we can listen and perceive sound coming from all over the place because we are 3D guys. We have a 3D listening device that is called our brain, that was created by God or nature or whatever you want to call it. Okay, and we are trying to emulate that experience with technology, and technology is giving us the chance to make it as crazy as you can imagine. Okay, as you can see in this mini cinema, and again, the most important thing is the dream, the vision of the person that is creating the space. Our role in the food chain is to convert that vision into the audiovisual and systems integration experience seamlessly as possible, invisible as possible when it's required, and to have magic spaces that can be used for whatever program the room intent was. So I think that we are now ending the lecture for today, and we are open for questions for you guys. Thank you very much, and I will stop share my screen so we can see each other, and we are now open for Q&A. Okay. Here we have a question from Carla Gomez. How dangerous is 5G that we keep hearing in the news? 5G is not dangerous. What is dangerous normally is the people around any kind of technology. 5G is not dangerous. It's just waves of content flying through with a different bandwidth, a different protocol, but 5G is not dangerous. It's the possibility of people using that network, okay, and using those signals to process content that could affect our lives. That's the dangerous thing of it, in my understanding. Okay, thanks, Carla. And so again, if you don't have any further question, we will be sending you the information, the certificate, both the AIA and the non-AIA certificates for you guys. And it was a real pleasure to be able to share our experience in this field. And we have another question. Okay, what measures do you take to stop interference between high and low voltage circuits? Basically, distance, okay, trying to have at least a feet between both signals, okay, trying to avoid 90 degrees intersections when they are close to each other. So if we are using trays, that is a very common way of managing. We're trying to separate them both in the horizontal and in the vertical plane, and this is it. The beauty is that today wiring for low voltage is normally shielded. That means that it has a natural coating, a natural protection core to for that purpose, to avoid interferences. But again, when you're talking about main voltage or high voltage and low voltage, that's why we try, if we are sharing the same room between electrical panels and low voltage panels, we try to keep it in two opposite walls. Okay, that will allow us that not only the placement of the panels, but also the management of the wiring through the room. Okay, it is possible to transmit 4K video with surround sound over AVIP. Yes and no. You will need a lot of. There are different decoders that allow us to use AV over IP for 4K. Instead of using 2 cables, you will need to use 4 or sometimes 8 to manage the size of the bandwidth and the size of the data that needs to be transmitted from one point to the other. You can use fiber, but the answer is yes. In some way, we are now witnessing a transmission of some kind of signal, not 4K because we are being compressed by Zoom, but we are using a lot, more than you think, compression for 4K and being transmitted using IP, basically. I hope that answered that question too. So again, thank you very much for your time. I hope that this lecture was positive for you, and we will have a second version of this, like the advanced version of this. We will go deep into this this subject, okay, in a second lecture that will be announced through the same network. And of course, if you want to get a copy of this lecture, no problem. We can put it available for you guys in our FTP site. More information will be developed sooner. Okay, soon. So again, thank you very much, and have a wonderful, wonderful, wonderful afternoon. Stay safe, and bye bye.